Welcome to the Deep Dive. Today we're taking a look at something pretty important, Europe's energy scene and how it's changing.
That's right. Specifically, the North Sea, how it's moving towards green hydrogen.
Exactly. And for you listening, staying on top of these big shifts is, well, it's key. We know you need the important info quickly.
And today we've got some news reports, a detailed study looking at a region, famous for fossil fuels now aiming for clean energy.
Right. So our mission today, get to the heart of this. What's the potential? What's actually happening? And crucially, what are the roadblocks?
And the scale is quite something. We're talking potentially up to 45,000 tons of green hydrogen a year.
From an area known for oil rigs. It's a huge shift.
Yeah.
Really quite remarkable.
It really is. The North Sea, for decades it was all about oil and gas for Europe, a real cornerstone.
But now it's running a totally new script.
Exactly. And the existing infrastructure, the offshore expertise, that actually provides a pretty valuable foundation for this clean energy future.
Even though it was built for something else entirely.
Right. It's fascinating how a place so defined by one energy type is now leading the charge on another.
Okay, let's dig into that. Why the North Sea? Why now for green hydrogen? We usually think oil and gas there.
Well, the big answer is wind. The winds across the North Sea are incredibly strong and really consistent.
So perfect for offshore wind farms.
Exceptionally good. And that massive supply of renewable electricity is exactly what you need for green hydrogen production.
Right, green hydrogen. Maybe just a quick reminder, why is it so important in this whole energy picture?
Sure. So green hydrogen comes from electrolysis, splitting water using electricity.
And the green part is key.
Exactly. When that electricity comes from renewables like North Sea wind, the hydrogen produced has basically zero carbon emissions.
Huh.
The Science Direct study we looked at calls it a vital component for energy evolution. And importantly, it highlights how it can strengthen energy security systems substantially.
Meaning less reliance on imported fossil fuels.
Precisely. Locally produced clean energy, that helps reduce exposure to, volatile global markets.
So the same sea that powered industry with oil could now power it cleanly. And the amount of wind power, they're talking about 300 gigawatts. That sounds enormous.
It is. That's comparable to, numerous large conventional power plants put together. It's a really ambitious vision.
And that scale of renewable electricity could seriously change Europe's energy mix, right? Help hit those decarbonization targets.
That's the goal, yes. It paints a picture of greater energy independence and a real move towards sustainability.
But it's not just about sticking turbines in the sea, is it? There must be technological advances driving this.
Oh, definitely. There's some really interesting engineering happening to capture more wind energy effectively.
Like what?
Well, there's this thing called the wind catcher system. Think of it like a sort of floating wall of smaller turbines designed to grab more energy from the wind.
Interesting. A wind energy wall.
Yeah, sort of. Innovations like that, plus improvements in standard offshore wind farms mean a more clean electricity available specifically for making hydrogen.
And didn't one source mention something about the sea itself being an advantage? The depth?
Yes. The fact that large parts of the North Sea are relatively shallow, that's a big plus.
Why is that?
It makes installation and maintenance of the turbines and the future hydrogen facilities quite a bit cheaper, easier to manage.
So that helps the economics of the whole thing, makes it more feasible.
Exactly. It makes the whole green hydrogen plan more attractive, more achievable financially.
Okay, so this isn't just theory. There are actual projects starting up, governments getting involved.
Absolutely. We're seeing real action.
Yeah.
There's a green hydrogen pilot project in the southern North Sea. It's a team effort between Centrica from the UK and a French company, Lhyfe.
A pilot project. What's the aim there?
Basically, to prove it works offshore, can you actually produce, store, and then distribute green hydrogen out there at sea? They need to show the whole system functions.
And Lhyfe seems pretty bullish on it. They mentioned coupling electrolysis with storage offshore.
They did. Colin Brown from Lhyfe called it an exciting opportunity. He talked about large-scale offshore production and how pairing it with storage is key.
So produce it offshore, store it offshore.
That seems to be the idea. It helps ensure you have a steady, reliable supply, even when the wind isn't blowing quite as hard, for instance.
And governments are noticing. The UK, for instance.
Very much so. The UK government actually doubled its target for low-carbon hydrogen production recently.
Doubled it. Wow.
Yes, up to 10 gigawatts by 2030. And they specified that at least half of that should be green hydrogen.
That sends a pretty clear message about their priorities.
It absolutely does. It shows they see hydrogen as strategically vital for their energy transition.
And it fits with their bigger goals, like moving off fossil fuels and hitting net zero targets.
Exactly. Martin Scargill from Centrica Storage was quoted saying, hydrogen will be crucial for decarbonizing the UK's power supply by 2035. It's seen as, well, essential.
Now, that study you mentioned had some projections for the actual build-out of this offshore electrolysis. It suggested the start might be a bit slow.
That's an important point, yes. It depends heavily on economics. If hydrogen and electricity prices stay low, the study projected maybe only 0.2 gigawatts of offshore capacity by 2030.
Okay, so not huge initially under those conditions.
Right, increasing maybe to zero point 0.7 gigawatts after 2040. It just highlights that the ambition is huge, but the actual speed depends on costs, tech development, and critically, the right policies being in place.
Okay, so that leads us nicely into the challenges. It's not all smooth sailing, clearly.
Uh,
What are the main hurdles to making this North Sea hydrogen vision a reality?
well, there are several big ones. First off, coordination. You've got multiple European countries around the North Sea.
Right. They all need to be on the same page.
Ideally, yes. Aligning regulations, investment plans, that kind of thing. It needs a joined-up approach to be truly effective, creating a smooth, efficient hydrogen market across borders.
Makes sense.
Money, inevitably. Securing the huge upfront investment needed for these large-scale projects, that's a major hurdle.
And the technology itself.
Needs to keep improving. Bringing down the cost of electrolysis, making it more efficient. That's crucial for green hydrogen to compete economically.
Okay, funding, tech improvements, coordination, anything else.
Well, there's the whole integration piece. How do you actually get this hydrogen into the existing energy system? Storage, transport, finding end users.
That sounds complex.
It is. It requires really careful planning and strong partnerships between governments and private companies.
That public-private collaboration came up in the report, didn't it?
It did. The report basically said success hinges on sorting out these obstacles, and that means specific policies and good public-private teamwork. It's a shared challenge.
But if they can overcome these challenges, the upside looks massive. Less reliance on fossil fuels, new green industries.
Exactly. Europe gets a chance to tap into this huge renewable resource in the North Sea, boost its energy security, and drive economic growth in sustainable sectors. It's a really significant opportunity.
So the potential for the region to become a global leader in clean hydrogen is real.
Absolutely. If they can harness that offshore wind power effectively, keep the innovation going, and have strong government backing, yes, it could really become a world-leading hub.
Okay, so let's quickly recap our deep dive. The North Sea is emerging as this major potential hub for green hydrogen.
Driven by all that offshore wind, new technologies, and growing government support.
But, as we've discussed, there are real challenges: funding, coordination across countries, technology costs, integration.
Definitely significant hurdles to clear.
Still, the potential impact on Europe's energy future is undeniable. And for you, listening, understanding this shift is vital. Seeing how these old energy regions are becoming leaders in the clean transition.
It's a transformation happening right now.
So, a final thought to leave you with. Think about the geopolitics. If Europe successfully develops this large-scale domestic source of green hydrogen, how might that change global energy dynamics? Who relies on whom? It's a big question.
A very interesting one to ponder.
You can delve deeper into the specifics by checking out the source material from IDR. If you found this deep dive useful for getting up to speed on this topic, please do like, subscribe, and feel free to leave a comment if you have more questions.